Orientation. The leak shows up at stage 4, the output, but it's seeded earlier, in the weights at stage 2 and the data at stage 0. There's no break-in here. The model just answers, and someone else's data rides along. 2 flavors: data the model memorized in training, and data that bled in through the session or retrieved context. We'll separate them, then gate each one. Sensitive Information Disclosure, OWASP LLM Row 2. The model remembers and answers with someone else's data. This is a defensive episode. We show the attack flow so we can defend it. The leak surfaces at S4 inference, but it's seeded at S2 model and S0 data. No break-in, the user just asks, and the model just answers. The danger is what rides back out with that answer. Scene 1, the benign frame. A user sends a cyan query in, an answer comes back out. There's no exploit, no jailbreak. The whole episode is about what hitchhikes on that answer. Path A, the model memorized. Rare, sensitive strings from training can surface verbatim, an email, a name, a record. Here, Jane at evil.example was baked into the weights, and a benign query lets it walk back out. Defense for Path A, a green gate upstream of the model. Scrub and minimize training data before it ever enters the weights. The record is redacted to bracket redacted bracket. If it never goes in, it can't come back out. Path B isn't memory, it's plumbing. 3 sources feed the context window: a retrieved doc, a prior session, and another tenant's row. Patient do fake 01. That other tenant record slides into context and rides back out to the wrong user. Defense for Path B, an access control gate on the context edge. Authorize every document and row entering the window for this specific user. The other tenant's record is stopped at the gate. The model can't leak what was never allowed in. Now a shared green gate on the answer edge, the output filter, defending both lanes. When raw PII tries to leave, it's minimized. Jane at evil.example becomes bracket email redacted bracket. Return only what the task needs, never raw records. And bound the memory itself. A differential privacy dial on the training path caps how much any single record can influence the weights. Even if a record slips past scrubbing, it can't dominate the model. We visualize exactly why that works next episode. 2 leaks, told apart by where the data came from. Memory, defended by scrub, minimize, and differential privacy. Bleed, defended by access controlling the context. Both backstopped by one shared output filter. A different gate for each path. The model remembers and answers with it. Next episode, why the fix is adding noise on purpose. Differential privacy, visualized. Break it on the board, not in prod. 2 leaks. Memorize training data which you fight by scrubbing and minimizing the data before training. And session or context bleed, PII, retrieve documents, other tenants' records, which you fight with access controls on what enters the context. Output filtering backs up both at the edge. And differential privacy bounds how much any single record can ever contribute, which is exactly where we go next. Why adding noise on purpose actually works. Break it on the board, not in prod.